Just like that, just like that. Good, yup, 1, 2, 1, 2. Yup, 1, 2, 1, 2. Yup, 1, 2, 1, 2. Yup, 1, 2, 1, 2.
Okay, so just getting here, everything set up. Just be a few more moments while I tweak a few things. Had to switch over to a new computer with a brand new install of Linux. I am very surprised that things are going as easily as they are. So just be a few moments here while I kind of dial everything in. All right, gonna go on mute for just a second while I check volume levels. Testing 1, 2, 3. Testing again. Okay. So, noise gate seemed to be doing its job. Testing again. Testing again. Okay, well, I think that's going to be as good as it gets. Maybe I do need that compressor. One moment. Testing, 1, 2, 3. Okay, that's a bit more noise taken out of the room. Okay, I think that should do the trick. All right, cool. So I think first I'll just do an overall overview of the Zodify kit itself. As you can see here, it is a bit of a 40% version of the original Zodiac or the Zodiac Pi. Some of the additions are the EZ-VIK connector on the back end there. It does have a dedicated spot for a brand new 3D printable roller encoder. Currently printed out of resin here. Let's get the kit pulled out. Just switch scenes. Okay, cool. So, zoomed in real quick here. So as you can see, it uses an extended Pro Micro footprint. It supports both the 35-pin generic RP2040 Pro Micros, as well as the Nice Nano and the, AliExpress rip-off versions, the Super Minis. Do note that it does require either a Nice Nano Super Mini or the 35-pin version of the Pro Micro. We'll get one of those out here. As you can see, that has the extended footprint on it for the bottom. Easier so you can point things out. So yeah, it does have the extended footprint on the bottom for additional pins. Additional pin kind of caddy corner in here, 2 additional pins over here that use 2mm spacing, and then up here you've got the boot pin for being able to put it into boot mode without having to remove it from the board itself. So I do have provisions for buttons for both of those here. It also uses the Lil-CC footprint for side-to-side communication with USB-C. As I mentioned before, it also has the additional encoder holes for the 3D printable encoder setup with screw holes to be able to mount it directly to the board. And if you are going to be using this for non-wired wireless like ZMK split, instead of installing the Lil-CC, you'd be installing a power switch right here. Moving on to the back side. As you can see, you have the EZ-VIK footprint so that you can either install it directly onto the board or use the daughter board with very large test points and mounting points for that. Pull one of those out as well. And just to kind of go over everything that comes with the kit here, you do have your choc Hotswap sockets, your per-key LEDs, which are 3 milliamp each instead of the 12 milliamp normal ones, so that you can run them without having to worry about lowering your brightness. Your diodes, and let's see, what's the rest of them at? Oh, here you go. And your down-firing underglow surface mount LEDs here. For the larger parts, it comes with your 2 Lil-CC C2C boards that are surface mount. In the same vein, you also have your EZ-VIK mounting setup for your VIC connectors. And then just, standard push buttons for your reset and boot. Capacitors for power smoothing for the LEDs. And resistors for setting your split hand pin. So, and that's really all you need to get this finished. The only thing that you'll be supplying yourself to get this operational is any kind of encoder you would want to use, whether it be the 3D printed one or not. For the 3D printed one, I'll be linking the project on GitHub that includes where to get the hardware and what type of hardware to get. I will also be selling the roller encoder style, like mouse wheel encoders, once I get those stocked on the website. I will be selling a few extension kits as well for ZMK that'll come with the toggle switch and the battery connector and a pre-pinned battery cable so that you can hook it up to whatever battery you wish. And then whatever you would need to connect the board to the main PCB. So you would need either Hotswap sockets and some sort of pins, something like these guys right here, the large pin strips. And then typically I recommend using something like mil-max pins here. Quite a few of these on like Mouser, DigiKey, things like that. They're very useful for this. Don't have to worry about like diode pins bending. These are pretty robust. And then usually you'll just you'll place down your pin sockets and then kind of solder those down, making sure they all line up, and then cover them with some painter's tape and poke through your mil-max sockets to make it hot swappable. Or you could risk it and just throw on the regular, straight pins and just permanently attach the MCU. Not necessarily what I'd recommend, but it is an option. All right. That pretty much covers everything about the board itself. Should be a fairly straightforward build, especially if you've done any kind of builds from like Finger Punch or even most of my old builds, such as the Zodiac Pi. So pretty standard, fair stuff here. So nothing really crazy on this board. I will point out, if you are running a Pro Micro, you just have to bridge these 2 jumpers up here. The ones labeled Pro Micro Enable. If you're not using a regular Pro Micro and you're using wireless, you would leave those unbridged and you would do the wireless encoder enable. So that's taking over the RX and TX that would normally be used for side-to-side communication and move that over to the encoder, so the encoder works. The ZMK firmware is pretty close to done. All I really need to get finished is the ZMK Studio integration, so that you can change your key map on the fly, as well as getting the encoders to work, and then optionally trying to get the LEDs to work as well. It is in a functional state currently, and I can link that distro, or the branch I have for the auto build on my webpage. So, like I said, just do note that that is currently in in production right now, but we're looking to figure out just a few more things to get it to kind of a fully featured state. All right. So as you can see, the final product, there's support for quite a few things here. You have the, for this one, I have support for both the larger touchpad here or the smaller 43mm touchpad from Azotech, and mounting plates available for these on my GitHub as well. As you can see, that is pretty dang big. I was running this for a while, but that one makes a lot more sense. And as for this one, since you have such widely available pads here for the EZ-VIK, I did hand wire on this this screen that was originally I was going to use for the Prospector ZMK dongle, but I figured it fit pretty perfectly on this. And so that you could see it as well, I did make a 3D printable tilted mount for it, so you're able to see it straight on. I also have multiple cases available. I have the main kind of, just standard case where you have the standoffs to the plate, nice sized hole for accessing your boot and reset switches if you put them on the bottom, as well as a nice chamfered edge for the entire pan there. Beyond that, I do also have a large 15-degree tilted case for ZMK users that has a spot for a 18650 battery holder. I'll be posting that one here in the future, but I do have a working prototype, and it works pretty well. It's a big boy at that point, but it's quite useful. Yeah, and with a 4,000 milliamp battery, you don't really have to worry about battery life either, so that's pretty cool. All right. So I'm just going to get a few things prepped here. And just a note about the choc spacing, just do be careful about your choice for your keycaps, just to make sure that they fit within the new choc standard, which I think is like 18 by 17 millimeters, and you should be good to go. I'm currently getting my resin 3D printer kind of back up and running after some failed flexible resin experiments, and I should be able to start printing out some of the resin like KPL, KLP, I can never remember what order, the Lame or Lame, whatever we have. Oh, I have the same one as Bomb. I got the Saturn 4 Ultra 16K, the one with the tilting vat, tilted and heated vat. So instead of just pulling the build plate off of the FEP, it just tilts the bed away so that the peeling forces are a bit more distributed than just trying to rip the whole thing off the FEP at once. And it's been very, very successful for just regular resin. Now, for flexible resin, apparently the tilting vat is a bit of a detriment because you can't quite get it far away enough for the stretchy stuff to kind of fully rip off. So it's not quite meant for some of the alternative stuff, but like the Soraya Tech fast resin that I've been using, the ABS one, the prints have came out amazing. I've got some Soraya Tech Blue, which is the more like sturdy, hard resin with a lot of impact resistance. I'm going to try to print some keycaps out of those. Maybe mix a little bit of fast to make it a little bit easier to print. But yeah, I think that's my this week experiment to get that going. Yeah, keycaps it's been great for larger things like cases. Then you get into the whole thing of resin support theory, which the resin community is a bit more try hard and harsh about things than the FMD printing community, because a lot of the people there are printing out like minis and things like that, and they're selling them. So they tend to keep stuff to their chest a bit more than the FDM printing community. So just be prepared for that if you get a resin printer. I will have to say that as corny as the guy is on YouTube, Uncle Jesse's got a lot of great videos on just basic resin printing stuff, and it's definitely a large mind space shift compared to like FDM printing. So you do kind of run into some conventions that don't quite make sense until you really wrap your mind around them. All right, so I think first things first, as I always start off, just going to do the diodes here. And as it seems like a lot of people who build these keyboards make my keyboards their first ones, I'll be a bit verbose about this as well, just because I haven't really done like a full start to finish explained build guide since the Zodiac Pi, like 2 years ago, year and a half ago. So dump these little guys out. Yeah, it's nice because I can just upload this full stream on YouTube and then use the chapter functionality just so people can jump around to see how you solder diodes, how you solder this, solder that. So yeah, you and the rest of the Finger Punch crew have been very supportive about this one, and I'm glad I got a lot of positive feedback about it. Wish I would have gotten it done a little sooner, but you know, my job sometimes goes from having a lot of free time to having no free time, and so it's just kind of bouncing back and forth. I'm just glad I was able to figure out ZMK firmware, to be completely honest. That is, as much as I like doing this stuff, sometimes the firmware side of things can be a little confusing for me. Especially when I'm bouncing my head off of, does it want me to do rows and columns on the actual keyboard, or does it want me to do an arbitrary, like, lineup? Is it, you know, is it taking into consideration the order of the keys and, like, the default transform? It's been a learning experience, and the fact that it's got to be so far away from QMK is interesting as well, because they can't use any code at all from there because of the license restrictions. So the conventions are very, very different. But at least I got the groundwork laid out. I think the only thing that I am not looking forward to is trying to get like a Circuit touchpad working on it, because that's going to require me trying to figure out the SPI stuff. Yeah, we know a guy. I don't like to bother the guys too much because we've got both guys in the server. But yeah, they're both extremely helpful, and I'm very happy that they're part of the community. I'm only bothering him more when I try to make a electrocapacitive, like Topper style version of my keyboard, because I'm very interested in that. Because I tried out some Topper keyboards at the Chicago meetup, and it has reignited my want for the Thock. So, like, I really, really like the feel of those EC key switches. So I'm just gonna have to steal some of his work and try to remold it. I guess the only thing that I'm not looking forward to is a 4-layer design, because that's going to be very expensive. But as long as people are willing to pay, I'm more than willing to make. So we'll just have to see how that works out in the future here. If I can even wrap my mind around it. Oh, that's awesome. Let me get this straight on here. At least one of us does. Let's pull this up just a smidgen. Maybe I can counteract some of that by... Yeah, that's a lot better. A little warped, but too bad. Okay, so starting off with diodes. So diodes are going to be one of the components that you're going to have to pay a little bit of attention to, because they are, they do have a polarity to them, which is indicated on these boards by a couple things here. So if you get real close in here, let's look at one diode footprint. Are you gonna focus? Yes, no, maybe not. Maybe I need to pull out a little bit. Okay, there we go. So as you can see on the diode footprints, I do have the universal diode symbol with the arrow pointing to the line. I also have a very thick white border on the side that the line on the diode would need to go to. So when you are lining your diodes up, typically they're going to have the A4 or T4 labeling on them, and then a line that's going to tell you exactly which side you need to use it on. So if you look at this one right here, you can see it's got the T4 markings, and then the line is on the right, lining up with the thick border over here on the right side, and the line over here with the arrow pointing to it. So that's going to be the direction that you are installing all of the diodes, and it is reversed on the other side because it is a mirror of this one. So just pay attention to where those lines are and you should be fine. Typically what I like to do first is just to go over the entire board and do the right hand pad and put some solder on those first. So then I can come back in with my left hand with the diode and the tweezers, and then come back with my soldering iron in my right hand, and then place it down, remelt the solder, and kind of push it into the melted solder, pull the soldering iron off, and allowing it to solidify while I'm holding the diode in place, so it doesn't go floating off. So that's kind of the idea on that. So I'm going to start tinning all of these pads here. Actually, let me bring in my jank makeshift fume extractor here. Maybe one day I'll get a real one. And, ooh, I'm running real hot on here. That is probably far hotter than it should be. I was pulling some pins out of a Zao that I'm using for a dongle, and I forgot about that. I'm actually thinking of venting this stuff out into my attic, if I can get permission from my wife to, you know, make a giant hole in my ceiling. And for whoever might be asking in the future or watching the video, I typically like to use the Peinzel. It's one of my favorite soldering irons that I've used for smaller work like this. It can hold a decent amount of thermal mass for larger stuff, but is very versatile for the smaller electronics as well. And for my solder, I typically use the Kester. For this one, I'm just using the leaded one. Let's see here. That is the SN63PB37, and that is just the regular rosin. I do have a no-clean version of it, but a no-clean version of it is just not as good. I'll probably try using it again once I run out of this stuff, which I am very sadly close to running out of my favorite solder, but I might just end up getting more of that. It's an excellent investment. I spent about $30 on it, and it lasted me for about 4 years at this point. It's a lot of solder. I'm also going to be wetting the pads for the capacitors as well, just since I'm doing this. Now I'll also do the split hands resistor, as well as bridging the 2 Pro Micros, since this one's going to be a wired one. Just to point out a few more bits of like bridgeable jumpers here. We have the VIK enable. That's more of just applying the 5-volt to the VIK connector. Otherwise, it turns off the 5-volt pin. This is for if you're connecting a Circu, one of the Circle touch pads, since they don't quite follow the Circu standard. And if you left 5 volts on there, just be applying 5 volts to a random pin on the Circu MCU. So I give you the ability to kind of turn that on and off depending on what you're plugging into that side. However, I do recommend the Azotech touchpads instead of the Circu ones. So, all right, moving on to the next side here. All right, moving on to the diodes. So, as I mentioned before, I'm going to get close up. People who are not used to doing this. And probably move it up just a smidgen. Okay, so as you can see here, I've already kind of pre-tinned this pad right here with some with a ball of solder. So the idea is you typically want that on the right side that you'd be coming in on, so that you can hold the diode in your left hand and remelt the solder with the soldering iron in your right. So I usually just kind of drop it a little bit to get it flat, re-grab it with my tweezers. I come in, I melt the solder over here, and just slide the diode in until I can kind of see the pad on the left, the shiny portion of it. I let go, give it a little bit of a wiggle to make sure it's solidified, and boom, that's one side on. And then once I'm finished with that, usually I'll do all of them, and then I'll come back around, flip the board over, and then come back in and solder on the other side of the diode here. So let's get that up there. And that's as easy as just getting a little bit of heat applied to the pad and the leg and just kind of shoving your solder in between until it melts and you see it kind of blob onto both of the pad and the leg of the diode. And there you go, you've got a successful connection. All right, I'll move through these fairly quickly. Let me zoom you back out real quick. The soldering iron that I typically recommend is a nice cheap Printables. Got a couple of them here. So that's going to be your USB-C power delivery version of a soldering iron, so it makes it pretty easy to travel with, carry, things like that. I've actually got two of them. I've got a dedicated old one for heat insert stuff. So I would say finished is a bit of a generous term there, Sandwich. It works. Wouldn't say it's finished yet. But it's definitely usable. I just need to get the encoders in, ZMK Studio, and then maybe some LEDs. But as for like being able to use like keyboard layout editor and things like that to make your own key maps and stuff like that, it is functional. That took an entire day of trying to figure out how they wanted that set up. So it's a bit goofy compared to the stuff that the QMK wants for how your keyboard's laid out. All right, here we go. Time to get these all installed. I said different. I didn't say bad. Pete shouldn't come after me for that, I don't think, maybe. So I think my next project is going to be something using one of these big, huge... One of these guys out. Yeah. For my next project, I think I'm going to try to use one of these guys. This is the F405 MCU with an absolute buttload of I/O on it. So I can get a keyboard that's using like Drashna's like beautiful like screen layout that he's got. I do have a board already built out, and somehow I've actually used all of the pins. So for like future SD card and a bunch of other stuff that's compatible with it. But yeah, the 3-hour copyright-free retro wave soundtracks on YouTube are definitely my go-to for music. There are a lot of loud noises. I think they're doing garbage pickup on a Saturday. Weird. I'm so glad this is a 40%. So much less to solder. The one that I've got kind of planned out for the F405 MCU is going to have a function row and a macro or a column on the outside. So it's going to be like a Zodiac Pi Plus. Debating if I want to make those removable or not. Oh, did I throw that on right? Sure didn't. I didn't follow my own rules. So, just as a reminder, make sure you're always paying attention to where the line is, since this is flipped. These ones too. All right, so just going to do a quick visual inspection, make sure I didn't miss any diodes. So we got the encoder, those four, that one, 3, 4, 4, 3, 3. Yep, that did the trick. All right, got 3, 3, 4, 4, 4, 3. Extra key, diode, thumb cluster. Yep, go on that as well. All right, cool. So the next thing I'm going to move on to is, since I've already kind of pre-soldered the pads here, I'm going to do the 4 capacitors for each side. So all of them are underlined here. Those are for smoothing the current that is going to each row of LEDs. Technically, design-wise, they do say that you need a capacitor for each one of the LEDs. That's not necessarily true. You get pretty much the same results if you put a larger capacitor close to each row of them. So that's why I only did need to do like 4 of them, and I've not personally observed any flickering or weirdness with that. So, and then the other thing I'll be doing is adding the split hands detection. The resistor for that. Just as a note, if you are making this fully wireless, you do not need to put a resistor on that, as it already kind of knows what side it is. It doesn't need a resistor to tell which side it is. Since ZMK, when you make the firmware, it makes a left and a right firmware. And then you have an extra little pad here to use for another pin for whatever you would like if you want to get creative. All right, cool. So, going to move on to doing the capacitors first. And decided to I got extras right here. And like I said before, the capacitors are not polarized, so you don't really have to worry about if they're in the right side or not. They're just really short, so just make sure you're not accidentally bridging them. So, if I can get this to cooperate here. Same idea with the diodes. Oop. Oop. Soldering iron went off. But I didn't move it enough. There we go. Just melt the solder, bring it in. This one's not agreeing with me at all. And there we go. Capacitors. There. Okay, so there we go. So now, just so we don't forget, this step is just flipping the board over and soldering the other side of all of the capacitors and diodes that we just added, just so we don't forget that step. And just to kind of give you a reference, I've been using the soldering iron around 145 or 150. we'll be lowering this when we move on to the LEDs to prevent it from frying them. As for soldering iron tips, I'm just using the simple cone soldering iron tip. A lot of people for these smaller ones like to use the chisel style tip. I find those to get a little bit too flat on the board with all this stuff kind of really close. And can cause you to accidentally kind of flow solder onto some of the Hotswap sockets and things like that. So I typically prefer the pointed cone style tips for my soldering irons for this. Oh, so up there. Time for the other side. It's way too precise. Okay. And to finish this off, we're just going to add the resistors before we move on to the larger stuff. And for the split hands pins, we typically just want a 10K resistor. I include these larger flat ones. Also, they do not have a polarity, so no need to worry about that. And that typically goes right here on the underside of the MCU. All right, looks good. Send over. All right, those are done. So just as a side note, I do include spots for resistors for 4.7K for both the SDA and SCL lines. For I2C, 90% of the stuff that you'd be putting on here already have the diodes included, or not diodes, resistors included for that on the signal lines. So you don't have to really worry about those unless you're doing something weird, or using an I2C device directly off the device, off of like the I2C header down here, below the VIK connector, that doesn't already have the I2C data lines pulled up. So just as a heads up on that. All right, cool. So next thing we're going to move on to are the Hotswap sockets. So Hotswap sockets for choc can be installed either way. They are a mirrored design, unlike the MX Hotswap sockets, so you don't really have to worry about how you are putting them on. Just have to slap them in there and hit them with solder. I'll just start off by doing this first small row. They usually just drop in and sit flush against the back of the PCB. From there, I will say the only thing annoying is that they recently made a design change where instead of it being a kind of U shape for the actual socket itself, they added this little tab up top to simplify the manufacturing process. But it does make it a little bit more difficult to kind of get your soldering iron on there and get your solder to flow in there. But with about the same technique, it's not really that big of a deal. So typically what I do is I will take my soldering iron and just place it touching the pad and the bottom of the Hotswap socket metal, and then just kind of feed the solder in right where they kind of meet until I see it kind of creeping up on both the actual leg of the Hotswap socket and the pad itself. At that point, it should be on there pretty well. Can't pull that one out. Yeah, and then you just repeat the process. So as you can see, just want to make sure, I'll do it one more time real close up here if I can. There we go. Maybe turn the light down a bit. There we go. Perfect. So yeah, just take the soldering iron, touching both the pad and the Hotswap socket leg, and then putting the solder right where they meet. And as you can see, it flows onto both the leg and the pad, making a solid connection. And then usually I put my finger on it, just to make sure it's nice and flush, and then remove the solder and let it solidify. Just be careful where you're putting your finger down. If you touch any of the metal on the side that you've been soldering, you can burn yourself. So just a heads up on that one. It's a nice solid connection. So I'm going to go in and just fill out all the spaces for the Hotswap sockets and get moving on that. Tighten this a little bit. There we go. That's a lot better. Okay. Right, now that I got all the Hotswap sockets populated, just gonna go in and start soldering them. Okay. This takes up a lot of solder, so I think I'm just gonna do that directly from the roll here. Escape. All right, flipping to the next one here. Just a reminder, we will be coming back to that side to fully button up the other ones. Take it easy, Sandwich. Thanks for joining. Alright. Just gonna slap all these on at once. Uh-oh. Oops. Yeah, you get back down there. There we go. All right, so just doing a visual inspection, make sure that I've added all of the Hotswap sockets that I need. So 3, 3, 4, 4, 4, 3, extra thumb cluster. 3, 3, 4, 4, 4, 3, extra thumb cluster. Okay, looking good so far. So next step would be to button these all up and hit the other legs with solder. At this point, it's probably the easiest part of the entire setup here. Uh-oh, somebody's trying to sell me views. Shouldn't AutoMod take care of that? All right, just going to get the other side here. One side done. All right, well, here we go. So we're at about what I would probably consider the halfway point here, considering that the LEDs do take a little longer to take care of versus the rest of the components here. But hopefully we can blow through that pretty quickly and get most of the stuff done that we need to here shortly. I'm going to take a quick break. I actually just have a package show up here. And I will be right back. Let me just make something for that. Boom. There we go. Okay, so I will be right back while I grab that and get a drink, and we'll see you in a few. Alright, I actually just had a new microphone show up during the stream, and I'll try that out real quick. Oh, that sounds pretty good. I'll try that out real quick. Okay, just going to mess with a couple settings here, and then I can get started back up. Testing. Okay, looks pretty good. Just gonna boost the mic just a smidgen. I think that should probably do the trick. Maybe a little bit of heat on that. Okay, that probably sounds good. Okay, cool. I'll get started back up here. Alright, so we left off after doing all the hot swap sockets. Next up is going to be the LEDs, the per key LEDs. So those are going to be the ones with the little legs on them to make them a little easier to install. My keyboard tray out of the way. Alright, so let's get this open. Dump them out on the table here. Alright, so going to bring you up closer real quick here. You going to focus? There we go. So, as you can see, for each LED, I do have them numbered, and then each pin has a letter next to it, representing what it's for. So, if you look here, G is for ground. Ground is always going to be the pin on the LED that has the notch in it. So this one right here, as you can see, it's got the little diagonal clip out of the leg there. You would just flip this guy over so that the LED is facing downward, because this is the one that's going to be lighting up the key switch that is going to be on the other side of the board here. You drop it into its little hole so that the legs line up with the pads next to the letters. And then what I typically like to do is just do one side at a time, just like with all the other bits I've been doing. As for your soldering iron, let me pull you out just a smidgen here. Usually the temperature of 360, 350 is a little too high for these. You do risk burning out some of the elements within the LED itself. So typically, if you're new to this, I would highly recommend taking it down. Oop, that's a little too far. Taking it down to like 290, possibly up to like 300. If you are a bit more experienced, I can recommend that you can do like 310, 315 to just kind of get through these a little quicker. If you know that you can hit it real quick with some heat, get some solder on there, and then pull the heat source away so that you're not soaking the LED with heat. So let me just show you. I typically do these. Bring you back in. Focus. There we go. Perfect. I'm going to actually burn myself off a bit of solder here instead of using it directly off the roll. Okay. So coming in from the side here, just going to touch both the pad and the leg with the soldering iron very quickly while applying solder. Ooh. Sometimes it doesn't want to stick there, so let me just... Boom. As you can see here, it looks like it just stuck to the leg. It didn't quite make it to the pad, so hit it again for a second. Yeah, that looks like a good solder joint. As you can see here, I can't really move or remove the LED, so that means that it is tacked down. So next up, what I would recommend doing is hitting the next one below it. This one should be a little more readily available and good to go because it's not ground. The ground is soaking up a lot of heat because it's connected to the ground pad on this one. So there you go. Got 2 legs done. So I'm going to pull out and populate these a little bit and start getting these. Now just be aware that the ground does change depending on where you're placing them. As you can see here, on this one the ground is on the bottom left instead of the top right. That's because it snakes through the actual board. So ground follows depending on which way they're pointing. And as you can see, it does switch again when you go to the next row. Now the ground's on the top right. Another easy way to tell is that the pin with the ground on it typically has the number pointing towards the ground as well. So that's a good visual indicator of where you're supposed to be orienting these. And last, it is flipping one more time here at the bottom. Oops, this one on that is also full. That's the end of the run. I'm just doing a small visual inspection here, and let's get tacking these downs. The person who asked if I'm about to wave solder the board, unfortunately, no. This is all by hand. Don't typically have any kind of wave soldering equipment at my level at this point. Oh, this one here. Just heat back up. So for this, currently this is, flux core resin. It's typically been enough for me. When I use like some of the no clean resin, typically I'll use a little extra resin with those, but these seem to flow perfectly fine for me so far. And as for grounding the board, I don't quite have an MCU or anything on it at the moment, so I don't typically ground those until I start putting the MCU on. But I do appreciate the suggestion. Just typically I'm doing the ground pins first, and those take a second to soak up enough to start flowing correctly. That off on. Oh yeah, I've been soldering for about a decade right now, but yeah, I always have stuff to learn. All right, cool. On the last little row of this one. All right, got that side all done. Gonna flip over and tack the rest of them down here. This part is always a lot easier because now that they're tacked down, they can't really move. Makes it hard the first time around is that typically the solder likes to kind of pull on the little tiny LED and get it out of its socket sometimes. So I have wasted a lot of LEDs in the past with that happening. Now I can kind of fly through these a lot quicker because I'm not worried about the LED coming off with the soldering iron. Missed a few over here. Okay, quick visual inspection to make sure I didn't miss anything here. Okay. This one's looking a little suspect, so I'm gonna hit that one again. Oh, it's looking quite suspect because I totally missed that side as well. This is why you check your work. All right, looking good so far. Now to do it again. Oh, well, thank you. Yeah, I like to contribute that a lot to the solder choice and my iron. I have made a lot of these keyboards considering I design them. have to make a lot of prototypes, make sure everything works right before I start selling them to people. So, thank you very much. Oh, solder I'm using is Kester rosin core. It is the SN63PB37. So that's typically what I use. Sadly, I am almost out. So I do have some of the non-flux. Well, it is a flux core, but it's the no clean that sadly ripped off. And I got quite a bit of that left, so it gets a little runny and probably needs a little extra flux if I was going to start using that one. But the flux on the regular rosin core Kester seems to do the trick for me, at least, as long as I don't sit there and cook off all the rosin before I'm finished flowing a joint. Let's get this right here. Ignore the sirens outside. Sometimes I use the solder dragging effect to my advantage to kind of pull the entire LED to one side of the slot or the other, so that these pins are better aligned when I come back and work on those. Only one that ever really gives me problem is the ground pin, but that's because I have a very large ground pore. Pretty much everything you see on here that's not a trace is ground. So it's got a lot more copper to heat up. You counteract that by going a little hotter, but at that point, if I go too hot, I can start damaging the LED itself. Yeah, if you hit these and leave too much heat on them and let them soak up too much heat, the little tiny gold wires that it uses to connect the really, really tiny IC to each individual red, green, and blue LED and unsolder themselves from the inside of the LED, and then you'll just have like green or blue and red, and you'll be missing one of the colors. Get some solder. That is getting really hot in my fingers. Do real quick. Oh, see, that one right up. Give this a flip test. Nothing fell out. The other side. Oh, so this is a split keyboard. This is one half. Here. This one is one of my designs that I've tested pretty well, but this one is for another friend in the St. Louis keyboard community, so I figured I'd just build it on stream so I could do a build guide for people who would buy a kit. You can find the link to my my shop in my profile, so if you're interested in a keyboard kit. Oh yeah, I'm not necessarily into the super high performance mouse side of things myself, but I have seen some really interesting ones that are super small. I think the first one I saw was called the Titan 1. I think it's made out of like a titanium 3D printed body. Um, and you kind of hold it almost like a pen. Very interesting, but as you can see, I've got massive hands, so that's a little hard for me. Yeah, he makes very limited amounts of kits, but if you follow the Discord, you can usually get your hands on one. I think he might be moving to resin 3D printing instead of titanium to kind of bring down the price. But he was kind of going for like the lightest weight that you could possibly get. And the highest response time. I think the weird thing that he did is that instead of when you're pressing one of the mouse buttons, you're not actually pressing down the switch, you're actually releasing it. It's like a backwards lever, so it's pulling off of it, which apparently is picked up by the microcontroller quicker than you're actually pressing it. Not sure in real life how much that makes a difference, but theoretically it does make it quicker to respond to button presses. Yeah, I'm not necessarily far too picky about my mice. I just like having a lot of side buttons for like copy, paste, delete, backspace, enter, you know, especially when I'm working on designing these boards for KiCad shortcuts and things like that. Do a little visual check here. All right, looking good. Okay, so now that we've done the larger LEDs, or the smaller ones technically, now we can move on to the downfiring underglow LED. Get a close up of these in a second. So pull them out of their strip here. Well, it looks like I might have lost views. Oh, no, it's still going. It's just quiet. See if I can find a better mix here. See if that works. Oh yeah, I can see that since it's closer to the wrist, you don't quite get the exaggerated movement from any kind of wrist flicks. I can see what you mean by that. All right, for these downfiring LEDs, as you can see here, the same thing typically applies. Let's get down close real quick. Focus. Okay, cool. Get a little closer here. It's gonna let me. Okay, excellent. So, as you can see here, we've got the surface mount pads for these LEDs. These are a little nicer than most because they do have some exaggerated pads on the edge, which make it a little bit easier to get solder to flow onto them from the pad. So real quick here. A little blown out there, but I can do that. So as you can see, I do have a 1 and like a little tiny strip next to the ground pin over here. That's going to correspond to the notch in the LED itself. Going to be a little hard to see here, but you can see it's on the top left corner there. There's a small notch in the housing to indicate the ground pin. So typically the way I do it is kind of similar to diodes. I'm going to tin one of the pads real quick here. Gotta let my soldering iron come up to temp, but go over here, place that usually on like the voltage or whatever you've got over here to the right. Put a little ball of solder on there. And from there, pick up the LED. Liquefy the solder on the pad. Kind of slide it over. Just kind of touch on the pad on the LED. Give it a second. That's on there. Now you can also follow up and get the other side done here as well. There we go. I think I got it. And that's anchored on there. So we'll continue with the rest of them, and then we'll circle back and do the other side. Just pay attention to where the number in the line is. That's going to indicate where you're going to want the notched corner to be pointing. I'm going to go through and get all of these with solder. Right, bottom right pad. And there are, let's see, 1, 2, 3, 4, 5, 6, 7 per side. And as you can see, they do flip depending on where they are. So these 4 over here are going to have the ground pin on the top left, whereas the ones on the bottom row over here, so this one, and this one, these 3, they're going to have it on the bottom right. Take it easy. Thanks for joining. Looks like I lost me. follow that one a bit. You know, just to be on the safe side, since I do include a couple free LEDs. I was fighting with that one, but I think I might just remove it. Try with a different one. Solder on this. Just going to do the other pin on these side for these I did up here. Just be careful not to bridge anything. You don't need a ton of solder for this. Flip her over. Put the other two over here. Did I miss a hole? Yeah, I missed like 2 of them. Oops. Got so focused that I totally missed those. Okay, cool. Flip it back around. Side. Okay, that's all the LEDs on this side. Just got to do the same for the other. We should be good with all the small parts. Well, small surface mount parts, I should say. So same idea, just make sure you follow where the ground / number line is pointing for the orientation. Should be good to go. Just a smidgen. That's on there. Alright, got all those tacked down. Just get all the other pins here. Right, and then flip them and get the remaining. All right, cool. So that is all the LEDs. Next, we're going to move on to some of the larger parts on the back. There's a couple parts that I'll be doing at the very last on this side, but for now, the last bit will be this and the buttons. So for the EZ-VIK, we're just going to solder one of the corners here. And then just kind of move this guy in. So we've aligned everything. So could be tweaked a little bit down on the side here. Keep applying heat to that until you have all 12 of the pads kind of aligned with their like little edge portions here. And then from there, you just solder her down. Get a little bit more solder. little extra solid on this guy right here. Alright, that looks great. Let's repeat that on the other side. Almost had it perfect. There we go. Should be good for me. Let it just a smidgen. I'm viewing it from an angle, so yeah, there we go. That should be good. Alright, that's looking good. Now, for the most finicky part of the build, is installing your Pro Micros. It's not really high stakes, it's just a matter of getting your pin alignment correct to make sure that everything lines up, fairly okay. So, I'm going to start off here real quick by just pre-snapping all of the sides. So this one right here, I typically do, let's see, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13? Is that 13? Yeah, that's 13. So 13 on each of the two sides. Then typically I'll do 2 right here. So these 2 sets of 3 are going to be for your nice nano. So if you were doing a nice nano, you would just, for the nice nano, I think it's either this one, or for the super mini, you do these 3. And then you would be done. But since we're doing the RP 2040, I just got to line it up with all of this. So just note that we got that extra pin down here on the bottom left. So typically I'll just do 2 of them down here, so that's a little easier to solder. I'll just snap those off with some side cutters. And then these 4 right here. Note, since you're going to be shoving these in between, you might want to try trimming a little bit off the side here. Make sure it's a nice, easy fit. Perfect. There's all of your main outer ones. And then you've got the one boot pin. I'm just going to probably use the smaller ones for that. I'll put the small one. Are you small? I'm pretty sure you're regular sized. Yeah, you're regular. One more. There. Alright, so I do have some smaller pin headers, since these 2 pins over here are going to be 2mm instead of the standard 2.54mm. Also going to use side cutters to pop those apart. Perfect. And then just a single one is needed for the boot, and I'll do one of the small ones for that as well. Alright, so now that I have all of my pins, I'm just going to remove all of the extra ones and just kind of start with one. So, typically what I do is just I flip the board over, set it down on the pin header, get my solder ready, and I'm going to take this up from 315. I'm going to pop that back up to the standard 350 because we're not working with, not really working with anything else. I think I'll do like 165 just to make this quick. So what I'm going to do is I'm just going to press down. I'm going to hit this with a little bit of solder. Now I'm going to hit that again and just kind of wriggle it until all of the pins are kind of centered over the holes. So, as you can see here, it is a little off to the right, so just going to put it back down, hit it with some solder again, and turn it until it's nice and even. Take another look. Yeah, that looks quite straight. Back to the bottom here. Yeah, that looks pretty good. And with the one in there, you can just kind of press it, nudge it where it needs to go, make sure that it is a nice, even, kind of squared up against the board itself. From there, you just flip her over. Since that one pin is holding everything else in, let's just get the opposite side. Flip it over, and that's looking pretty good. So let's finish by putting the rest of the pins together with solder here. And for the upcoming steps, I would definitely recommend having some blue painter's tape available, just to kind of help hold things together since we are kind of trying to line these small ones up. Okay, so that pin header is in there. Alright, let's do the other side. Actually, we'll do this a little differently. I'm going to try doing these guys. These end up being a pain sometimes. Let's just flip it over. With these, the pins are a little longer. So what I like to do to kind of keep them in place is just fold them over while I'm flipping the board. And that should allow you to kind of line them up. So, there. I hit them with a little bit of solder. With the other pin, I'm just going to melt the solder again, not touching the pin that I'm hitting with the heat, obviously, but I'm melting the solder and kind of maneuvering it until it looks straight. Definitely do this at your own risk, but yeah, that makes it look pretty nice. And then, not quite together. And let's say it looks a little bit off to the side here. What I can do, since I've got it soldered that way, is kind of push them, bend that a little bit over. Let's look at it from the bottom here. A little tilted that way. Let's just try to bend it up a bit. Okay. I think that should be good enough. Cool. And let's get the other pin real quick here. Same idea with the boot pin. We stick that through. holding it off to the side here while we put it down. And then just kind of use the mat and then make sure you try to find the center of that hole there. It's pretty centered to me. You can kind of see it is a little close to that side, but easy enough. You can just kind of press it where you want it to go. Let's just do a little fit check real quick before we move forward. Laying your MCU down, lining it up with the sides there. Oh yeah, everything's looking pretty good. The boot is a little bit off center. You can kind of see that in there. It needs to go up and to the left quite a bit, so we can fix that real quick just by brassing it a little bit. Try it again here. Just a little bit more to the left and it should be good to go. Oh yeah, that is now perfect. I can see right down through it, through the holes here. Alright, cool. So next one up is probably going to be, I would do the two larger ones here to just make sure that this goes in flush. So, put that in there. You even do kind of the same trick where you're kind of pulling the pins on the bottom over to the side to create friction so that it doesn't fall over. And then you just set flush with your workstation. And yeah, should be good to go from there. One recommendation is definitely do one pin at a time, so that you can adjust it as needed, so you're not fighting both the pins. Okay, let's flip it over and make sure that that looks good. Pull over. Just put my finger there. Get this out real quick. Who did that? Oh yeah, that's nice and flush now. As always, you can just do a quick fit check here. Yeah, those are all lining up pretty much perfectly. Alright, next up will be the 4. Go down here to fill out the rest of that. Let's just do the same trick here. A little over to the side, flip it over, down. Then just kind of wiggle it against your workstation to kind of get it centered. Looks pretty centered. And just get one of them tacked down. Alright, let's give it a flip. Those look a little down, but since we only got one plugged in there, kind of press it, get it nice and lined up. Looks good to me. Now we can tack down the other 3. Oop, and I totally forgot to tack down this guy, so let's do that as well. Okay, cool. So now just need to throw in the last 13 pin on this side. Let's do a little bit of a fit check here. Do that. Yeah, everything's looking pretty good. Same idea for this one. just tack down this side right here. Press it down, and pull it over to the side so it's flush up against the other side here. Flip it over. That's looking pretty much near perfect. Okay, I'm gonna nudge this over as far as it'll go. Do your final fit check. Yeah, and I can pretty much see into every single one of those sockets. So, let's do the final approach here. Get the rest of these pins tacked down. All right, there we go. Looking good so far. Now next thing is I'm just going to take care of some of the larger parts here as well. I'm not going to do the Lil-CC yet. I'm going to save that for... probably not a bad idea to do that now, just so we're not obstructing it. So let's do the final top part here. Lil-CC, which is your C2C interconnect board. And we're going to do this same as we've done most of the other surface mount stuff. We're just going to hit that bottom right pad here. Take our Lil-CC board and we're just going to line it up and need a little bit of tilt there. Yeah, there you go. It is now lined up with all of the pads here. So there's a bit of wiggle room. You can move it a little bit more over each way and kind of line up with the pads. Not really super precise fit needed for this, as long as it's making contact with the pads. To flow the other three on this side. These four on this side. Now, like I said, if you were doing a ZMK wireless build, you were not going to be using you're not going to be using the Lil-CC, since that's specifically for side-to-side communication. Instead, you would be installing one of the small micro switches on the bottom here, or on top over here, so that you can turn the battery on. Alright, so that one's done. Let's get the other one. Honestly, this might be a little easier to do before you put on the Pro Micro headers, just because you've got a lot more space to work with on the top here to slide it in. Tweaked a little bit up into the right. I'd say that looks pretty primo. All right. We're approaching the end on this one, so let's get the buttons installed real quick, and then we can move on from there. What with the rest of the buttons? That's a question. Right over here. Alright, so we got 4 push buttons. For a QMK build, if you're using one of my 3D printable cases, as you can see, I have a hole on the bottom of it, so when the board is mounted inside the case, you have full access to the boot and reboot buttons from the bottom. So I'm going to install them that way for this one. Now, if you are doing a wireless build, I might recommend installing them facing up so that you have access to them when they're installed in the case, because the tilted case has room for a battery directly underneath it, so there's no way to kind of access them from the bottom without disassembling the keyboard and reassembling. Just going to install the facing downward. Made it a little bit difficult on myself doing this after putting in the pin headers, but oh well. You can learn from my mistakes. All right, and let's just get the pin headers installed with this side as well. All right, 13 on each side. Oh, that didn't break right. Try that again. Go. Here, one pin. Got some spare ones up here. Another one pin off. There we go. Thirteen. 2 for these two. Four on the bottom here. And then we're just going to make sure that the edges of these are pretty well cleaned up, so they fit flush. Then the tinier ones, we'll just need the 2 for those two. And then the single for the boot. Alright, let's do this. Like I said, just tack one down. It's still heating up. Okay. Definitely a little crooked there, so heat it up. There we go. Now let's straight. Get the rest of them. That looks pretty good. Let's do the large twofer. The extra inner side pin. Oh, that's a small one. My bad. That's the large one. One pin, take a look at it. Looks good to me. Ooh, last one, sorry, 1 second. The small two. Oh, if it didn't just slide off the board and into my lap and the floor. Go. That'll be embedded in my foot later. Nope, nope, there they are. For these, just try to make sure you place the smaller side towards the next one so that they're not interfering with each other. Flip that over. Get one of those pins. Then hit it again. Nothing to do. Straighten them out. Let's just do the single pin real quick. let's do a fit check. So the two over here are looking pretty good. The boot actually needs to come inward a smidgen. Bend that a little bit. Down a smidgen. Yeah, perfect. These two guys need to come a little bit. Oh. This one's kind of floating a little bit. Let's get that end up here. Yeah, that's close as I'll probably end up getting it. Okay, let's do the bottom four over here. Get them centered as we can get them. Back one down. Those look pretty good, to be honest. Just to confirm, we can check here. Oh yeah, that looks perfectly fine. And then the last bit is this. I'm gonna do two because I'm pretty certain that's, yeah, I get stand two and down just a smidge. Just permanently place all these. Alright, so there we go. Got Hotswap sockets all done here. Looking pretty okay to me. So next up is the fun part of actually getting the Hotswap sockets installed. Well, the sockets, not the sockets, the pins, making the actual MCU hot swappable. So for that, zoom you out a little bit. What I recommend is a bit of painter's tape. So get yourself a nice sized chunk of painter's tape. Kind of get that shoved in there a little bit. You can kind of see the edges. And then just press it down, and with your fingernail just kind of hit it so that you can kind of see the outline of where everything is. From there, you're going to use your pins. And what I typically do is I'm just going to take the smaller of the three, the inner ones, and kind of pin those down first. Just so I have something to guide the MCU onto and I'm not trying to fight with those later. Order some pins. Alright, so what I'll typically do is I will find the boot pin, just kind of line that up, press it on through. As you can see, I have the pin sticking out of there. As you can see, it is in the Hotswap socket. I would probably get something large and flat, more like a spudger or something. Kind of just make sure that you can press these fully down. Now let's find the other two here. Down there. There we go, found one of them. Press that fully in. Find the other. There we go. Broke through there. Press that in. Okay. Now what we do is we take our Pro Micro, line it up, press it through, and boom. We now have our Pro Micro kind of lined up. So the painter's tape is going to keep the solder from flowing from the pin into the socket, making your hot swappable connection a permanent connection. So from there, we're just going to fill out the rest of these. I typically only fill out a few of them at a time. So I'm going to do the four corners here. Sometimes these just do not want to pierce the painter's tape. Kind of have to play the game with them. There we go. You'll feel it pop through. There we go. That's in. Through. Okay, so we got the four corners and then the extras in the middle. From there, what I'll do is I'm just going to solder those at the top of the MCU. So to make sure that these stay nice and even, I'm going to get the two farthest corners real quick. While that's still flowing, I'm going to press down the MCU so it's nice and flat against the painter's tape. Rinse and repeat with the other corner. And then I can continue as normal for the rest of them. Okay. So those are all done, 7 of them. So now at this point, I'm just going to snip them as close to the base as possible without scratching the PCB. Now typically what I do, since these Mil-Max sockets are pretty large, I'm going to flip them and use them for the next set that I'm going to solder. Now if they do have like extra solder on them, sometimes I'll toss them. Just kind of up to your discretion how you would do this part. One. And now we just rinse and repeat. A few at a time and solder them on just so I'm not fighting state here. back and refill the solder so it's nice and bald. And then the last one here, just snip that off, flip it over. There's the last Hotswap socket. Alright, there we go. So at this point, you have two options. You can either just rip off all the tape and leave it as is, but the way I like to do it, just to ensure that everything's nice and movable, is to actually pull the Hotswap socket out. Typically I'll do that by taking something like side cutters or something like a spudger and just kind of shoving it up underneath like the USB port and giving it a couple just to start getting that pried out. I'd also undo the tape on the sides and use that as like a way to get some leverage on these pins, and just gently start wiggling them left and right. You can start seeing I'm actually starting to pull it all out of the sockets. Just got to be pretty careful, because if you start getting to the point where they'll just pull out, you can kind of get it out at an angle, and then you might bend some pins. So just be very measured with how much force you're using. When you feel it start to give, just give it a little bit more, and boom, there we go. Get the tape off of here. Take a look. And there you have it, a perfectly pinned and ready to hot swap 35 pin Pro Micro. Definitely would give them all a little bit of a brushing just to make sure none are loose, but everything looks good up top, so they're making a solid connection. So at that point, you just line your Pro Micro back up, and then just give her a snap. And there you go. Your Hotswap Pro Micro is ready to go. And to be honest, the entire keyboard is ready to go. It is set up and ready for firmware flashing, which would be as simple as holding down the boot button while plugging in your USB, or if you're plugging in your USB to the Pro Micro, you can also get it into boot mode by holding reset, holding boot. So you would hold boot, tap reset while still holding boot, and then you can let go of boot. At that point, it should show up as a flash drive, and then you just drag and drop your U.2 file from your computer onto the Pro Micro itself, the flash drive that shows up, and then you're ready to go. Should come online, and you should be able to see all your LEDs. That pretty much concludes the build stream for this one. If you have any questions or would like to purchase any, you can go to splitlogic.xyz. Bring that up on screen here real quick. Yes, you can pick one up at splitlogic.xyz, and you can also find a link to our Discord in there. We have a very large community, and I'm fairly active there if you have any questions. Yeah, hopefully this build guide helps you out. And like I said, if you do have any questions, please feel free to reach out on the Discord, and me, community members, will be more than happy to help. Thanks for sitting through this 3.5 hour long build stream, and take it easy. Thank you very much.